Yeah. Okay.
Okay, cool. So we have started now. Okay, so I believe everyone are comfortable on DFS, right? So let's try to do two problems. Okay, maybe in case if you are interested, we can write a code. But yeah, so say you're given an again an undirected graph probably. Okay, something like this. Now you remember, right? This is what, one graph, not two graphs, correct?
Disconnected graph. Yeah.
Yeah. So this is one graph. This is not
Disconnected components.
multiple graphs. Now what I will be asking you is I will be giving you Q queries. Okay. In each query, I will give you two nodes, U comma V. What you have to tell me is, can I reach, if I start from U, can I reach to V or not? This is what you have to answer, true or false. Okay. Is it clear? If I'll
Yeah.
give you multiple queries. In each query, I will give you two nodes, U comma V. You have to tell me that if I start from U, can I reach V or not? Whether U and V is reachable. Okay.
Okay.
So how will you do this?
We can we can start from DFS of U.
Okay. Mm-hmm. And
Uh, One thing is we can check the visited array whether it has V as visited or not.
okay, nice. That's a good one. So everyone understood what did we say just now? That let's say something, maybe something like this. Okay, that we have U here. Okay, and let's say V is over here. So what Saha said is, let's do DFS, and since we know that if we do DFS, it will get visited, and if finally let's say V in the visited array is visited, I mean if it is true, then we can say that U is reachable to V. Okay, let's say V is over here and U is over here itself, and if we do DFS, this will still be false, right? Because there is no way you can visit this. Agree?
Yes. Yes.
So
Yeah.
in that time we will print false. Okay, that's a straightforward approach. Correct. Now
Yeah.
this works, but there is a small problem, that is Q is up to again 10 power 5. So in that case, what can we do? So okay, so did we discuss about the time complexity of DFS in the last class? I don't
No.
can
No.
know, right?
No. No.
So
No. No.
like the time complexity is big O of V plus E. Okay, just remember this. It's for V is nothing but number of vertices, E is nothing but number of edges. Okay, so it's V plus E. Okay. This is a TC, time complexity of a DFS algorithm. Now what happens if you do whatever Sahas just told? We can, the time complexity will be something like this, right? True. That for each query we will do a DFS and it will be V plus E, right? So obviously it will TLE. So we have to do something else. Now what can we look for? Think first. Uh, like before me telling the solution, please try to see what can we do. Can we do something else? Can we store some information probably?
If we know like what element is like are being like present in particular stuff, we can do it, right?
What element is present at particular stuff? So can
I
you
mean, like,
uh,
it's like we are given. Let's take this as three components, right?
okay. Mm-hmm.
So if we know like what queries being present in a particular component in a graph, then we can just know them, right?
What query? No, can you, I still did not understand.
I mean, see, you have three components, right?
Okay.
So if you are given a query like u comma v,
Mm-hmm.
so we can know whether like it's being like present in the first part or second part or third part, right? Like where the u and v is present.
Okay. Mm-hmm.
And just whenever I mean, if you just know where the breaks are, like where the components are getting disconnected,
Component.
whenever you're given yeah, I
Uh,
mean, attachment कुछ नहीं है ना, just नहीं है, just कुछ नहीं है ना दोनों के लिए.
Okay, fine. So yeah, whatever you're saying is almost correct, Deva, but I did understand, but uh, as I said, right, your presentation again is not that good.
Okay, see, okay, it's like we are given three components,
Okay,
and we are given a query like u comma v,
let's say
and
1 comma 10. Okay, now you tell me. Now.
yeah,
You tell me. Yeah.
yeah. So we are given 1 comma 10, right? So as we iterate to the graph, we can know how many components are being presented in the whole graph, right?
Okay.
If there are yeah,
Hmm.
yeah. So we will be like getting three components as an answer, right?
Yes.
So if we just store each component value in an like answer, or else if we maintain a sequence for a particular component, right? Then when we were given a query, we can just compare that and we can just know them, right? Whether
Okay. Yeah.
there's any connection or not.
Correct. So guys, can we say, let's say if we can somehow store each node to which component it belongs to, then is my answer done?
Yes. If
Right?
it's being written true.
Exactly, right? So can I say if component of u, okay, if it is equals to component of v, then I am done.
Yes.
Then it is true. Otherwise, it is false. Can I say that?
Yes.
Right? I can do that, right? So probably we can try to do that one. Okay. So while doing a DFS, we will try to maintain another information that each node belongs to which of the uh, component number. Okay. Now, the power of DFS is if you start from any node in any component, you will visit the entire stuff, right? So, if they are in different components, can I say they are never reachable? They will never reach, right? Even if you do DFS from here or from U or from V, they will never be reachable. Let's say this is U, this is V. Your V will only visit this component, your U will only visit this component. Now there is no way that U and V can be visited, right? So in that case, if I somehow maintain that U is a part of component 1, V is a part of component 2, since they belongs to different component, can I say they are not reachable?
Yes.
Yes.
Right. So and now you see that somehow from Q, that for each query we are just doing a constant check, right? We did it. Okay, so this is something known as pre-processing. Pre-processing is a very powerful technique, which is whenever you are given a query, think of something that can I do some pre-processing and can I store some information so that for each query I will take, let's say, login time or constant time or something like that. Okay, a very good example of pre-processing is something as sieve of arithmesis also. Okay, so let's say I don't know the prime numbers, right, up to maybe 1e5 or 1e6. So for each query, let's say if I have to iterate on prime numbers, then it's a very hard task, correct? So what we can do is we can do some kind of pre-processing to store what are the prime numbers available, something like that. Okay, but yeah, uh, I mean, coming back to the context, so are you guys clear now, like what we need to do in order to do this?
Yes, bro.
Okay, so let's take this same code itself, okay, DFS1 code, and we'll tweak it, okay, to see how we can write it. Okay, reachable dot java. Okay, reachable. Cool. So we have the graph ready. Okay, somehow the graph is ready. So what we need to store component number, right? So
Yes.
we can create an array int component number. Okay, let me initialize this component number. Now, so this array will tell me that for each node which component it belongs to. Okay, so what we will do is we need to pass some information, right, that which component it is. Okay, so we will start with 0, and let's say as soon as we are unvisited, right, in case whenever we see a node is unvisited, do a DFS from there. Okay, so what we will do, we will increase the component number, okay, and we will pass it along with our DFS function, right? Now what we passed is 1, correct? I mean in the initial case, int component number. Now can I say for this node the component number is this, so can I store that information in an array whichever we just created? We can do that, right? Right. And okay, so here what should I write? Should I pass the same component number or should I manipulate? Should I have to change anything?
No, pass the normal same comment.
Easy. Okay, why same? Because everything is in the same component, right? That's the reason we have
Yeah,
to do this.
and it's being changed in the external for loop, right?
Exactly,
In
it's
the
being
like,
changed here.
yeah, yeah,
Now what we will be having is, let's say we have number of queries to take, so we will take each query, we will take two nodes, we will quickly take two of the nodes, and if component of u is v, is this component number, okay, if they are same, then true, otherwise false. Okay, clear?
Yes, yes, ma'am.
So what we have done is we have done a DFS and we maintain for each of the node what's the component number it is. Okay. So shall we run for an example, or do you guys think that it would suffice? Okay, let's run for a smaller example problem. Let's say there are 6 nodes. Okay, and maybe we can take this two. Okay, so 1, 2, 3, 4, 5. Okay, let me write something. Okay, 1, 2, 3, 4. So 4 are enough, I guess. 4 edges, 0, 1, 0, 1, 1, 2, 2, 3. Okay, and we have 4, 5. Okay, so this is the DFS order. You can see it, right? This is the DFS order. Now we need to take queries. So let's say we are having 3 queries. Okay, so first we will take the 0 and 2. We are getting true. Why true? Because the graph is something like this, right? 0, 1, 1 say 2, 2 say 3,
Okay, okay.
and we have 4 and 5, right? So can you see this part, that 1, 0 say 2? I mean, if you start from 0 you can reach true. We can do that, right? That's the reason you're getting true.
yeah,
Let's take a counter example. It
Mm.
would be 2 and 5. Okay, and we would expect it to be false. Let's see, and we are getting it as false, right? So they are not reachable by any way. And
yeah,
maybe we can take maybe again 3 comma 4.
4 and
Okay, and again it's false, that is it's not reachable. Clear what we have done?
yes.
So these
yeah,
kind
bro.
of tweaking is only the thing which you need in DFS. Okay, DFS is very common. So what information you need, just pass it as a parameter or something, store some information and try to manipulate over that. Okay. Okay, so I guess you're clear, right?
Yes.
Yeah, clear.
Yeah, nice. Okay. So let's do one more problem and then we will move to the next part. Okay. Mm, okay, let's say you again have a graph. Okay, something like this, and there are multiple components. Okay, Now, your task is you have to add exactly one edge. Okay, your task is you have to add exactly one edge such that the number of components gets reduced. Okay, such that the component gets decreases. Now, if I add an edge over here, will my number of components are getting decreased?
No.
No. So this is not a valid one. Let's say if I add this one, is my number
Yes.
of components getting decreased?
Yes.
Yes.
Yes, right? From 3 it became 2 now.
Yeah.
Okay.
Yeah.
So the question is how many ways you can add an edge? Okay. Only exactly one edge. In how many ways you can exactly add one edge such that the number of component gets decreased? This is the question. I hope question is clear, right? Just a quick
Yeah.
yes if everyone is clear.
Yeah.
Yeah, yeah.
Can you repeat? Can you repeat?
Given a graph, okay, you have to add exactly one edge. Okay, you have to add exactly one edge such that the number of components in the graph gets reduced. Okay, now your question is how many ways you can add an edge such that the number of components get decreased. So this is one way. Okay,
Bro,
yeah, your
by
voice is
adding only one edge, only one component can reduce, right? Is there in other cases?
no, that's correct. If you add one edge, only one will be reduced. That's true, Sam. But the challenging part is in how many ways you can add the edge. That's the question.
Yeah. Okay, okay.
Yeah. So this is also a valid, right? This is also valid.
So we can find similarly like number of components,
Okay.
and we can store the nodes per component.
Okay.
So in this case, I think the answer is 4 into 3 plus 4 into 4.
4 into 3 plus 4 into 3 plus.
4 into 4.
Okay. 4 into 4. So uh is that enough, Sas, or do you think
We can
And
have even
3
two
into 4
into
plus
four.
3
Yeah,
into
three
4.
into four.
exactly?
That's 2 into 4 into 3. Yeah, exactly.
Right? So
Yeah.
good job, guys. Okay, nice. Appreciate that. So, so like Sahas and Deva, I guess you are totally in the path that you know how you have derived this, right? So, what about you,
Yeah.
Sam, Manan? Like, did you guys understand how did they come up
Yeah,
with
yeah,
this?
yeah.
I guess his network is not good, right? I mean, is it only for me or for others also?
No, no. Yeah, his network is a bit lagging.
Okay, okay.
Sampath.
So, Sam and
Sam.
Manan, did you guys understand this?
No.
Okay. See, what they have done is they have smartly saw this observation. Okay, this is the graph, right? First graph, second graph, third graph, correct? Right, this is the graph. Now can I say adding an
Yes.
edge in the same graph in the same graph doesn't make any sense, right? Because the number of components will still be same, right? So it's always useless to add an edge in the same component, but it's always beneficial and it's one of the potential answer for me to add an edge between two different components. Let's say this one, correct? If I add something from here and if I join something from here, can I say my number of components get decreased? Manan, hello?
Hello.
Yeah, did you understand this?
Hello. Yeah, this hello.
Yeah, you're audible, man, you're audible.
Uh-huh. Yeah, yeah.
So did you understand this, the observation?
Yes. Yeah, yeah.
Okay, so now you have
Mm-hmm.
added from one to here. There is one more way also, right? You can add like this, you can add like this.
Yes.
Okay,
Mm.
And there are more also, there are more possibilities. You can add this, you can add this, something like this, right? So from
Yeah.
each of the node from this component, from each of the node from this component, if you attach them, you are done. So how many nodes are there here?
Yes.
Four. How many here?
4. Connecting 3. Correct.
Right. From here you can attach probably to this also, right? Anything from here to anything from there, right?
4 into 4.
Yeah.
Yeah.
Now from
Hmm.
anything from this part to this part. So
Yeah. So yes. Yeah.
got it?
3 into 4. Correct.
Chalo.
I understood.
Yeah. So yeah, nice, Sas and Deva. Okay, good to see that. But how will you code it out? That's the main thing, right? ठीक है, ये तो हो गया. But let's say you have, will you store something like this 4 comma 3 comma 4 in your array list or something like that? And
Yeah, number of nodes.
so, are you thinking to do something like this?
Yeah.
Sas, are you also on the same?
And previously we have stored like in the component, right?
Okay, but how does that help?
So
Mhm.
I mean, he will count that the number of same pairs over there.
mm,
Uh, okay, no, you have to tell me properly because I still have confusion on your
I
part.
mean,
Wait, wait, wait. Let him tell.
comp.
He is
Okay,
confused. Let
done.
him tell once. Okay. So,
so we will, yeah. So we will be storing the node which it belongs to in like which it belongs which component, right?
okay. Mm-hmm. So something like this, right? So ये सब nodes है 0 1 2 3 4 5 6 7 something like this, right, Sas? So these are component number one, correct? These are component number two, correct? These are component number three, correct?
Yes.
This is the part, right? Yeah. Can you tell after this? This is what we have created using the code.
So
Hmm.
yeah. So we can uh, take
Mm-hmm.
variables and like take an other array and store
Store what?
and the count of that number.
4 comma 4 comma 3 comma 4.
Yes. Yes.
This is only, right?
Yes. Yes.
And after this, are you thinking to
Yes.
do like this? I mean, two for loops, 4 into 3 plus 4 into 4. ऐसा? Are you thinking like that? No, that's what, right? I guess. So, Deva and others, what do they say? Like, this is what we are thinking, right? 4 into 3 plus 4 into 4 plus
Yeah,
4.
yeah, yeah.
But,
Can we do something with contribution
Yeah.
technique?
Yeah. I'm also thinking that way.
good. Think in some direction, okay? Probably not contribution, but something you have already learnt. Manan, if you are there, please try to think. In the worst case, the problem is you will be again doing n square, right? So n square again would fail, right? Let's say you have something like this. This array will, let's say it is something like this. Okay, all different, only one component. Okay, and you have up to 10 power 5. So sub mein you will store 1 1 1.
And
Sorry.
okay, if you take the count of the fours and if you just multiply like the individual components and
No,
the whole value.
no. Now you are 4 3 4. Let's say you have something like 2 3 1 4, something, some numbers, some random number.
So
Mm-hmm.
first thing we can do is multiply all the numbers
Okay.
and iterate big of n like when we are at 2 divided by 2.
Oh, okay. So you are saying, no, man, that how does that work? I'm still thinking of, let's say 4 3 4. So
Yeah.
what you said is,
Multiply all the-
This only, right?
Yeah, so contribution of 4 is 12. Plus, when we are at 3 divided by 3.
Hmm. Okay. Is it like this? Okay. Let me give an counter example probably. Okay. 3, 4, 5, 6, 10. Okay. If we have like this, so you said like this, right? 3 into 4 into 5 into 6 into 10 by 3. Something like this, right?
Yes. Yes.
So so 3 3 goes, and you have 4 into 5 into 6 into 10. Okay. But the actual contribution should from 3 should be like this, right? Correct.
Okay, okay, sorry.
Okay. Hint. Okay, I'm giving you a hint. Prefixums?
You mean prefix multiplication?
No.
Oh, we have a wait. We have done this, right? I gave you a problem.
Huh? You gave me a problem. Nah,
I mean,
you
you
didn't
gave us a
give me.
problem.
Okay.
No. We just solved a problem, right? For the multiplication stuff, the balloons car.
Okay. Good, good. You remember that. So, this is what we need to find, right? Ultimately, can I say this?
Yeah.
Can I write something like this?
B plus C.
Bro, your screen is lagging behind. Is it for me or
It
for all?
same for my end also.
Yeah,
Deva, is it lagging? Deva?
yeah.
Sorry, bhaiya.
Yeah. A bit, man.
Okay, I guess
Your voice is up to the mark, but
there is this problem with
Yeah,
one.
the screen time is loading. Right.
Yeah, there is a problem with OneNote which I believe. Okay, whenever I am writing, it's little slow, so you have to kind of adjust. But yeah, what I'm
Yeah,
talking about
I
is
got it.
this. Okay, now is this a prefixum? Isn't this a prefixum? It's a prefixum only, right?
Yes. Like we can
Yeah.
consider suffixum also, right?
Ah, yeah, I mean anything, man. Okay, suffixum or prefixum, but
Yes. Yeah.
yeah, but this
Hmm.
is same thing, right? So now,
Yes.
Yeah.
if you see prefixum में big O of n में we can do, right? It won't take O of n square.
Hmm.
yes.
Yeah.
Yeah, so this is what you can follow up probably. Okay, and I don't think it should be hard for you guys to code it now. Okay, and look, this is easy, right, for you?
Yes.
Maintain a
Yeah.
sum and multiply. That's all. When you are at B, you since you maintained sum of C plus D, you have B into C plus D. Again in sum, do B plus C. I mean B C plus D is already there. You do a sum of B, so you will have B plus C plus D. A into whatever the sum you have. So that's all. Nothing else. Okay.
How to how to get this ABCD values optimally?
Same. What you can do is you can count it, right? This one we have this array. Ra. ये array
Hmm.
में what you can do is probably you can create a map or something like this. Okay, map of 1 is 4, map of 2 is 3, map of 3 is 4, right? So that's all. That's enough, right?
Okay.
Yeah, got it, no?
One second, bro. Like how we will be getting these numbers?
Map. Use a hash map. In hash map you
Okay.
can easily have a count, right? Key 1 is 4, 2 is 3, 3 is 4. Can we do this if you travel this one?
Yes.
And then you have 434 ready with you, right?
Okay, instead of okay, got it, bro.
Yeah.
True or false? Just only storing the which component one.
Mm,
That makes easy, right?
where is true false, man? I still didn't see true false.
Instead of like instead of visited array, we are doing true or false. We are
No, no, there is.
placing
Yeah. So what we did is we created this array, right, in the last question. If you see
yeah, yeah,
The
component.
component array.
Yeah.
yeah, yeah.
Component.
hmm Okay.
Okay. Clear, right?
Yeah, okay, clear.
Chalo. Manan, is it clear for you? Or
I will have to see some recording, I guess.
okay.
Just now joined. Yeah.
Okay. Okay. So DFS is this much. ठीक है मतलब obviously you will solve problems, that's different, but core concept is this. Okay.
Yeah.
Okay. So now we will move to a different one of the another algorithms of graph, which is BFS. Okay. This is nothing but this is breadth first search. Okay. Now first thing is, how is it different than DFS? Okay. And I mean, so if you guys remember, I did tell you that in trees there is no difference between DFS and BFS, right? Because it always has this unique property that from any node there will always be a unique part to another node. But in BFS, but in graphs it's not the same. Okay, the reason being, in BFS, like in graphs, you have cycles, so you don't know what will be the shortest path or whatever, something like that. Okay, so let's say you have something. Okay, let's say you have a graph. Okay, if I ask you that what's the distance from U to V, let's say this is U, this is V, and if you do a DFS, what's the problem? Can anyone tell me that?
There is a probability of, of longest path also.
Nice, good. So you understood, right? That what happened was from DFS, DFS is what? Recursion. And in recursion, do you have a control on that? No. So DFS might travel this, and it will tell you that, okay, the length is 3, but actual the length is 1, right? Correct. So that's the problem with DFS. So in order to kind of get rid of it, we have something known as BFS. Okay, so let's try to see what BFS actually does on a graph. Okay, and please listen to my points carefully, because these are the minute points which we kind of ignore it, but it's important for us. Okay, now let's take a graph. Okay, let's take some graph. Okay, let me number them quickly: 0, 1, 2, 3, 4, 5, 6, and 7. Right. Now, what we do in a DFS is, so right, in whenever we do a recursion, what happens internally is internally a stack gets created, correct? A recursion stack. But in BFS, we will try to maintain our own data structure, and that data structure is nothing but it's a queue data structure. Okay. Now, before going to that, okay, let's see how BFS actually works visually. Okay. So probably we can try to take, maybe we will start from zero itself, okay, because zero is something that we always try to take for. Okay, so we start with zero. What happens in BFS is, in DFS, if it was a DFS, can I say it would go from 0 to 1, 1 to 2, 2 to 3, 3 to 5, 5 to 2, 2 to 6, again come back and go to 7. That's the DFS,
Yes.
right? But in
Yes.
BFS, what we will do is we will try to explore something known as level wise. Okay, remember this term very carefully: level wise. Okay, I'm just repeating it again: level wise, because it's very important. Now we start with zero. What are the neighbors? Okay, so we will maintain a queue data structure. We push zero initially. Okay, we push zero initially. From zero, what are the points we can go to? I see that there is only one, correct? So when we popped zero, I mean, as soon as we pop, what we try to do is we try to visit its neighbor which are not visited. Okay, so from zero we have gone to one. Okay, is one unvisited?
Yes.
Yes.
Yeah.
So we will push 1. Now, from 0, can we go somewhere else apart from 1? I don't see any, right? So this is
Yeah.
what we are done with. Now, we are at 1, okay? Let's pop this from Q. Okay, we are at 1 now. From 1, where can we go? We can go to 0, right? But somehow 0 is visited, right? So we will not go there. Okay, if something is visited, why do you want to go there? We don't want to go there, right? Now, from 1, what are the possible places which I can go to? I see that I can go to 2. Okay, so if I can go to 2, let me push that. Okay, from 1, can I also go to 4?
Yes.
Yeah.
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 Okay, nice, that's good. Chalo. So from 1, I guess that's all where we can go off, right? So this is what the one's contribution or one part is, that it will go to this node and this node. Okay. Now we will pop out the front element again, which is 2. From 2, where can we go to? Can I go to 1?
Yeah. But it's visited.
Yeah, but it's visited, so we will not. Can I go to 3? I guess I can. So we can go to 3. Okay. Now, from 2, can we go somewhere else?
No.
No, just
No.
okay. Now, let's pop out 4. So from 4, can I go to 5? Yes. Can I go to 6? Yes. Can I go to 1? I mean, I can, but obviously 1 is visited, so we will not go there. Okay. And I don't see any further nodes, right? So we are kind of done with this also. So next node, which is at the front of queue, is something as 3. So from 3, can I go to 2? I can,
Yes.
because 2 is
But
already been visited. Can I go to 5? No, it's already been visited. So there is nothing to explore more from 3. Okay. So next we have something as 5. From 5, I see there are 3 options. 3, obviously we will not go. 2, obviously this is 4, we will not go. But 7 is still unvisited, right? So if 7 is still unvisited, we will just push it. Okay. And we are kind of done with 5. Now we will pop out 6. Okay. From 6, I don't see we can go to any other further nodes. So 6 is done. Let's pop 7. And from 7 also, I don't see any further nodes. So we are kind of done with the BFS. Okay. So this is how BFS works. So what actually you have done is, from each of the node in DFS, you would have gone straight till the point where you don't have any further nodes to explore. But in BFS, what happened was, from each node, you tried to go level wise. Okay. Now the magic of BFS is, see this queue very carefully. Okay. I'm showing you something. First segment, second segment. Okay. I've drawn some lines. And can you see what's that?
Kind of levels.
Exactly. That's the power of BFS. That if you see the lines, whatever the continuous lines I have drawn in different colors, can I say each color has different level? Like this is level 0, this is level 1, this is level 2, this is level 3, this is level 4. Can I say that?
Yeah.
Right?
Yeah.
So this
Yeah.
is what we have. Okay. So now if someone asks you, he bro, what's the distance from 0 to 5? Can I say it's very simply distance 3, because this is
Yeah.
the level, right? So
Mm.
uh, so unknowingly you have unlocked a
Yeah.
very powerful tool, that from here, if if there is no weight on the edges, okay, if you remember in the previous class we discussed there is something as weighted
Yeah.
bfs also. Since there are no weights, and let's take each of them as a cost one, something like that, then if you see, if someone asks you from 0 to any other node, you can quickly tell it that what's the distance, right? Because of the level wise exploration of the bfs. Okay, so this is the power of bfs. Okay, that from each node what you try to do is you try to go level wise whatever is possible. Okay, is bfs clear?
Yeah,
Yeah.
bro.
Okay, so now we will see a
Yeah.
standard, okay, template of how to code bfs. Okay, so probably
We'll be using two loops, right? One for queue and one for adjacent list.
one for,
Iterating queue and one for adjacent list, right?
yeah,
Like,
correct, correct. So yeah, for what we will do is, Sam, we will write it, I mean, okay,
okay.
okay, so we have just copied all the required things because it's again the same thing, right?
Mm.
Apps, adjacent
Yeah.
select, visited. Okay, now, so you remember, right? We have to, as soon as the node is unexplored, which is not visited, we will do a bfs. Okay, so from I equals to 0, we will start a bfs. Okay, now this is what we will look for today. Static, at any point if you guys are not understanding, please let me know. Okay, okay, so since we require a queue data structure, we will create a queue. Right, now as soon as you create a queue, do that. Since we will always, like, since we are starting from node, okay, can I say this, that we will visit this somehow, because we are starting from this node itself, right? Now
Yes.
initially, can I say only there will be only node, first node, whichever we are starting with?
Yeah.
Yeah.
Okay, now what we have to do, we have to explore
Not empty.
all the nodes. Okay, that is, if you have seen this diagram, we will try to pop all the elements, I mean each one of the element from our queue, and try to explore all the adjacent edges, right? So int current node, nothing but q dot remove. So if you do q dot remove, the node will be popped out. Okay, for simplicity probably we can print it. So current node. Okay, now the next task is we have to explore all the adjacent edges, right? So for integer neighbors, okay, so we will go to all my neighbors. Okay, so you remember this adjacency graph, right? I mean the data structure which we used to store a graph,
Yeah.
correct?
Yeah.
Yeah.
First thing we will check is, if first thing we need to check is obviously that whether it is visited or not. In case if it is not visited, what are you waiting for? Please mark this as visited. That is, you are finally going to explore this node. Okay, so if it is not visited, we will mark it as true. That is, we are going to visit this, and since,
Add to queue.
yeah, exactly,
And
since it
yeah.
has to explore other nodes also, we will go ahead and we will add it to queue. Okay, and somehow if you see, your BFS is done. Right,
Yeah.
Yeah.
this is it. That's all. Nothing
Yeah.
much, nothing fancy. Clear? Is everyone clear?
Yeah. Clear.
Yeah.
Nice.
Yeah. Clear.
चलो ऐसा रहो, मतलब if you take talk like this, I am also excited to explain all this. Okay, so let's run. Okay, let's see what we are getting. Slow. Okay, quickly someone tell me the graph. Let's take some random graph. seven nodes. How many edges? One, two, three, four, five, six, seven. Seven nodes, seven edges. Okay. Seven nodes, seven edges, and then we have to take the graph. Okay. So let's take 0, 2. This is 0, this is 2, this is 5. Okay. So 2 to 5 and 5 to 0 we have graph. 2 to 5 and 5 to 0. Okay. Remaining we have this one, right? Which is something maybe 1, 3. What are the numbers which are left off? Is it 1, 3, 4, 6? I guess, yeah. And we got something. Okay. So what we got is 0 to 5. So can you see that we start from 0, we will go this directions, right? So 0 will be there, then 2 will be coming out, okay, then 5. So this is the exploration of this component. Now if you see, we have something, let's say we start from 1. So 1, 3, 3, 4 will be pushed into queue. So let's say 3 is popped out first. From 3, 3 will push 6. So first 4 will come out, then 6 will come out. So it should be something like this. Okay. Now you see we got 1364, and here it is uh,
4 6
1346. Okay.
four
So
six.
somehow like we changed the order maybe, but yeah, this is how the DFS works, BFS works. So is
Yeah.
BFS clear?
Yeah, bro.
Yeah,
Yes.
bro.
Yeah.
Yeah.
So let's try to do this problem also, that given two nodes, I mean not two nodes probably, given a single node, you have to tell me what's the distance from this node to any other node. Okay. Okay. So
Yeah.
now what we will do is, so is the question clear? We will be given a single
Yeah,
node
yeah.
and we have to find the distance. Okay. Chalo. So instead of doing BFS from other nodes which are not visited, what we will do is BFS of starting node. Okay. And we will just take this input. Okay. We will do this. Now, do we need a distance array? We need a distance array, right?
Yeah.
Correct. So let me quickly initialize that. So whenever you're creating a distance array, always initialize that distance array with a large number value. And what does large number value indicates? That it is not reachable. Okay. So arrays.fill, maybe something 1e9. Okay. Which is a very huge number, which will tell me that it's anything is not reachable for now. Okay. Now, can I say as soon as I enter my BFS, can I say this? That since you are starting from that node itself, the distance will be 0, right, for that node,
Yeah.
right? So others, are you guys not clear of this yet?
Yeah, yeah. Got it. Got it. Got it.
No. In this, okay, what we will do is distance of
Neighbor.
neighbor
Neighbor.
is nothing but distance of my current node.
Plus
Can I
one.
write, can I write this?
Yeah.
Right?
Yeah.
That is for neighbor, whatever the distance we took plus extra, right? Because we have to go one more extra step to reach my neighbor. Correct. So that's what we have done.
Yeah.
Okay. And now if you see, your distance array is ready. That's it. Nothing else. We did not modify anything. We just added one simple line, and your work and it works. Okay. Now what we will do is, maybe we can try to take queries. Okay. We will try to take some queries, and we will see what's the distance. Okay. Int note to go, if my distance of node to go, okay, is equals to 189. Can I say it's not reachable?
Yes.
Otherwise, let's print the distance. Okay. Okay. Is it clear? This if just I wrote a if check that if it is not reachable, that's all. Manan, is it?
Yes, yes. Hmm.
Yeah.
Let me clear the console probably. Let's take the same example 7 7. Okay, we have 0 2, we have 2 5, we have 5 0, and we have 1 3, maybe 3 4, maybe 4 6, and what else? Let's say 6 2 1. Oh, did we miss anything?
I think we need to enter need to go values, right?
Sorry,
Need to go values.
which values?
Need to go.
Starting node.
I'm not understanding what you guys.
We need to
Array,
enter new value right now.
We're done with 7 edges, right? I guess.
Yes.
no, we should add which node we want to go. 23rd line.
Starting node.
Okay, okay, okay. This one, right? I guess. This one.
Yeah.
Okay, let's take three queries. So we got 314 as the uh, oh sorry, we are taking starting node, right? This is what 26th line.
Mm,
Okay, sorry. Yeah.
yeah.
So what we took is we took the number node 3. Okay. And where is node 3? Node 3 is this one, this component. Correct?
No, it's a component connected graph, right? We have taken,
No. See this
not the disconnected.
022550. 022550.
Okay. Okay.
Okay. So what we
Mm,
have done is we have done a DFS from not DFS, BFS from 3.
mm,
Okay. Where
mm.
is 3? This is the 3. So you should visit all the nodes, right? 1, 4, and 6. Or did I create something wrong or what?
You just remove the for loop, dude. I mean, if the starting point is
Sorry?
you want, okay.
I guess I've done something else. Okay, 022550. This is the graph 0250, and there is one more which is 1334. Okay, 1 3 4 to 6 and 6 to 1. Okay, so eventually we should get 3461 something like this, right? But we got 314. Why does 6 is not visited? That's what I'm concerned of. Hmm. We have added into queue. We have BFS from starting node. Not sure what exactly happened. Okay, let's take a small graph probably. Okay, maybe with four nodes. Okay, four nodes and three edges, right? We have 0 2. From 2 we might have 2 3.
2, 4. Hmm.
Okay, 0 to 2 3, which is okay. We will have one as separate. Okay, one we will keep it as separate, and we will, let's say we will add one more edge 0 to 3. Okay, which is the starting point? Let's say 2. So are we getting 203? So you got 203, right? That is, if you do a BFS, this all nodes will be visited, correct? Now we want, now let's take some queries, maybe probably two queries for now. Okay, so which node we want to reach it from? Two. Let's say if I have to reach one, and did I get the correct answer? I mean, not reachable, because it's not reachable from there. Can I say that?
Yeah.
uh, Others, are you guys not understanding or not interested?
No, no, got it.
Okay, what about SaaS, Sam?
Yeah, understood though.
Okay, so please acknowledge. Okay.
Yeah, yeah.
Okay, and from, let's say from 2, if you want to reach 0, it's only distance of 1, right? Okay, is it clear now, like what we have done?
Yeah.
That for each of the nodes, since we started, we will make it as 0, and as soon as we are going, we are updating this. In fact, in this question, the question to you guys is this needed? Is this visited array needed for this?
No, actually, because we are popping out the first time, right? Every time.
Mm-hmm.
So I guess it's not required.
Others, what do you guys think? Do we require this visited array? So if you see in the graph, what happened was, let's say you are at this node, okay? The distance is 1, the distance is 1, the distance is 2, right? Now, with 1, what are the nodes I'm going to? 3 and 6, right? So if you
Yes.
see, you only explore the nodes only once, correct? That's all. And there is no other way you explore it. From 6 you go to 4, you never go to 3 again, right? There is no way that you go to 3 again, correct? That means if I even don't keep my visited array, and if I try to manipulate with my distance, it does work. Okay, so I'm just removing this visited array for now. Okay, and what we will do is, if distance of neighbor, okay, you can write this also, that if it is not, what is 1e9, that is, it is not reached, correct? That's what we populated with, right? If you see here, no. So what does 1e9 indicates? That it's not reached. So if it is not reached, can I say then only we are visiting it for the first time? Quick yes, if you guys understand this point.
Yeah.
So no, Manan, isn't it clear?
Can you just repeat the statement of nine?
What does 1e9 indicates? We did you see
It
this? We filled with 1e9.
money nine.
That means it's anything is not visited. Okay.
Yeah.
So if it is 1e9, that can I say I am visiting it for the first time?
Yes.
So if it is visiting for the first time, it will update it, right?
Yes.
And then this condition will never occur. Can I say that?
Correct.
Right? So
Yeah.
this is how, when instead of BFS, instead of keeping a visited array, this also works. Okay.
Yeah.
And I'm just removing this also, because we don't need visited array. That's all. Deva, is it clear?
Yeah, bro.
Others?
Yes, bro. Got it.
Sam?
His internet connection is not
No.
there, so he just left the meeting and he'll join.
Okay. So you guys are clear, right?
Yeah, yeah.
Yes.
Okay.
Instead of
Yeah.
visited array, we are taking the help of
Distance. Yeah.
yes.
You can keep visited array also, there is no problem. But why to keep one more big of n space when we can do our work with this, right? Okay. Yep. So this is how the BFS works. Okay. Now let's try to do one problem probably. Okay, and then we will move to the next thing. Since I have to cover few other topics also, I don't think I can take many problems. Okay. Now let's say you are given a chessboard. Okay. You're given an n cross n chessboard, and you're given a knight. So everyone knows knight, right? Horse in your terms, if someone doesn't.
Yeah.
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 So how does knight move? In an L shape, correct?
Yeah.
So what you will be given is, you will be given a starting position of knight, okay, and you will be given some target position. What you have to do is, you have to tell what's the minimum number of moves required for knight to reach to target position from that starting position. Is the question clear?
Yes.
Yes.
Yeah.
Okay, so for this maybe we can try something. Manan,
3.
3. Okay, how is it, Sas?
First, what to tell this?
Right or up? You tell me that, I'll understand.
Up right, up 1, right the 2. Yeah. Yes, yes. Yes.
Okay, so the answer should be 3. Okay,
Yeah, correct.
right.
Mm.
And I don't think there is much shortest path than 3.
Yeah.
So 3 should be the answer. Now, since now, is it a graph first of all? And okay, before that, we should discuss one more thing. What's the time complexity of BFS again? So it's also V plus E only. Okay, remember for DFS and for VFS, the time complexity is same. Now, space complexity, quickly, someone.
We go often.
I mean V, N is V here.
We, yeah.
So why V?
Yeah, we,
Because
sorry.
first thing is we are creating something as distance array or visited array, and also there is one more which is Q, correct? So Q will also take V space, right? Because consider the worst case that almost all the nodes are in a queue. So in that case, you need a V space, correct? So this is the space complexity of BFS. What's the space complexity of DFS? It's again same. Okay, if you are kind of doubtful, why? Big O of V for visited array, and there is a stack space, right? Extra stack space, which is again big O of V. So that's the reason. So for blindly, you can remember that for DFS and BFS, TC and SC are same. Now coming back to our original question, given this knight and a target position, you have to reach in minimum moves. First thing, is it a graph? We don't have any nodes or
No.
right? Then why did we take this problem in a graph section? Okay, so when you encounter this kind of problems, that in a grid you have to go from you have to reach from one position to other. Okay, the problem is, can we do DP on this?
Yes, because explore all options.
But it's being like moved by
Uh,
3 elements at a time, right?
3 elements? Where 3 elements, man?
I
There is
mean,
only one knight, right?
it can go by L shape, right? So it skips 3 boxes, right, at a time.
So
Oh, okay. I mean, you can just add 3 to it, right? Okay.
so first thing, tomorrow you should tell me, can we solve this problem using DP or not? It's a homework. You just I have to identify whether can it be solvable using DP or not. Okay. Now,
Okay.
so what we are dealing with currently is, we have a problem that we are, there is a knight and it has to reach to some position, and we have to tell the minimum number of moves, right? Now somehow this is not a graph, this is a chessboard, right? And how this is a graph, but how this became the graph? This is not a graph. So can we use any graph algorithms if there is no graph at all? No, right? But it turns out to be, these kind of problems are modeled into a graph. Okay, so in graph there is the one thing which you have to become you have to become more perfect is how to identify whether a problem is a graph problem or not. Okay, so in this case, can you see that we have to kind of reach the minimum number of we have to reach in minimum number of moves, right? And you have certain directions to go to, right? So if I draw something like this, treating each box, each cell as a node, and each one of them as a edge, can it, is it getting modeled into a graph problem now? Like if we treat each cell as a node, as a round node, whatever we see here, if we treat like this, can I say it becomes a graph problem,
Yeah.
right? Something like this. Now, can I do BFS from here with certain conditions that I can go like this, like this, like this first, maybe something like this, and
Like the shortest path.
exactly. So now, did we model our problem to a shortest path problem now by seeing this, that from this node we can try to go up four direction? I mean, there are 8 directions, right, for a night, as I saw something like that, right?
Yeah.
So from a grid, did we model this problem to a graph problem? First question.
Yeah.
We are able to do that, right? So others,
Mm.
did you guys get the intuition what we have done just now? Manan says,
Yeah, got it, bro. Myself.
okay,
Yes, bro, got it.
got it right. Yep. Now,
Yes.
so we are given a initial position, right? Now, first thing, from x, let's say our Cartesian coordinates are denoted at x comma y, right, where we are starting, right? From x comma y, what are the positions I can go to? So if in a night, from a night, I mean, if I have to go by a night, at least how many directions total? How many possibilities?
8.
4.
No, it's eight, Sam. For
Oh,
night,
okay.
Eight.
eight.
Okay, okay.
If something like this,
Okay, 4 directions, every direction 2 options, right?
yeah.
Hmm.
Can I say these are the only 8 directions for a night, right?
8.
Okay.
Yeah.
Yeah.
Let's try to take this one. Let's say we are at x comma y and we have to reach here, this position. Can I say this is nothing but x plus how much? 1 comma y minus 2.
2 plus 1.
Is this correct? Do you guys think is this correct?
Yeah.
Yes, yes, bro.
What about this?
X minus 1,
X minus 1, or is it y minus 1?
y plus 2.
No, I'm talking about this one, Ram. How much direction you are going right plus 2, right? And how much direction you went up minus 1,
Yes, yes. Yeah,
Yeah.
yeah,
Sorry.
yeah.
right?
Yeah, got it.
Okay. How about this one?
X plus 2, comma
X,
y
X,
plus 1.
X plus 1, y plus 2.
Just a second.
Right? So, are you guys in a position to
Yeah.
write for this, and this also? I mean, you can write it, right? Easily.
Yeah,
So,
yes.
Yeah.
Yes.
since there are 4 members, let's write it. Okay. So, Deva, please go ahead and tell this one.
X minus 1, comma y minus 2.
X minus 1 comma y minus 2, right? So we moved up 2 directions and 1 direction left, so that's why this is correct. Okay. Manan, what about this? Quickly, please. Sam, tell this list.
X
X
X minus 2 y plus 1.
plus 1 और minus 1 ऊपर जा रहे हैं ना, y तो ऊपर है, this is y, this is x, right?
हाँ हाँ, so y minus 1.
Sam,
Yeah, x plus 2, y minus 1.
Is it x plus 2?
Sorry, x minus 2. Sorry, this side, back side.
X minus 2, and this is
X mi- y min y plus 1.
SAS
X minus 2, y
SAS
plus
X
1.
minus 1, y plus 2.
x minus 1 y plus 2, right?
Minus 1, y plus 2.
Right. So can you see from this positions I have, I can go only to this 8 positions, that's all, nothing else, right? So
Yes.
what we
Yes.
do is, if we are at x, okay, if we are at x comma y, can I say if I add plus 1 minus 2 I will reach here? From x comma y, if I add plus 1 minus 2 will I reach here? Can I say this? Ana bolo bhai. If we add plus 1 minus 2, can I reach here?
Yeah.
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 If I add plus 2 minus 1, can I reach here? In x, if I add
Yes.
2, if I
Yes.
do minus 1, I will reach here. Similarly for this also, if I add plus 2 plus 1, I will reach here. Okay. So what we will see is BFS 8 direction array. Okay. Okay. It's for 4 directions, 8 direction array for 9. See this one. Is this the one? Minus 2 minus 1. Can we see minus 2 minus 1 somewhere? Minus 2 minus 1.
Mm. Yeah, yeah.
Minus 1 minus 2. Somewhere it should be. See, minus 1
Yes.
minus. So they will go like this every time. Okay. Sam, you remember you asked me this question somewhere.
Yes, yes. Last time
Yeah.
in discussions.
So this is the array which we will use it. Okay. To explore. Is it clear? This dx dy array
Yes.
spoke to every one of you because you will use
Yeah.
it
Yeah.
very frequently. Okay. And there is a trick.
Okay.
Okay. If you remember the first row, okay, if you remember the first row, the second row is nothing but you have to start it from third element, I mean index 2, copy paste everything, copy paste everything, and paste this, I guess. Okay, I guess I forgot the trick, but there is this trick. Okay, you can always, but somehow in interview you don't have to, you have to show them this one. Okay, so you should write it by your own, but in contest you can somehow take it right. So yeah, but you guys got it right. What is dx and dy? Okay, now so from this node, what we will do is we will try to do a BFS. We will try to find a minimum distance. And as soon as we reach this, can I say I am done? I mean, not only this node, probably we can visit everything, right? In a BFS, since all of them are connected, it's a single connected component. I can try to do BFS from my starting point and visit every node, and I can update the distance. Okay. Okay. So shall we code this up? I mean, just to see how we can write this in code. Or do you
Yes.
guys think you are in a
Yeah.
position to?
Write the code.
Okay. So at least, are you guys clear what we have seen?
Yeah, bro.
Okay, nice.
Yeah, clear.
Okay, so let me take this. Okay, so what we require now? I mean, do we require anything? Graph? Do we require graph now? No, right? Because what they will give in the question is only n cross n chessboard size. That's all, and starting position and ending position. Correct? Okay. So what we will do? Let me take this n. Static int n is nothing but the size of the chessboard. Okay, n cross n, so n is enough to go ahead now. So we have taken the size of the chessboard. Okay, now what we need a distance array, right? Correct, because we need to compute the distance. So can we quickly create a distance array? Okay, and what should I initialize with, or should I have to initialize with something or not?
1e9.
Exactly. Why 189? Because everything is, assume that everything is unreachable, right? Or in kind of a very infinite distance. So what we do is we'll quickly fill this array up with 189, which will say that okay, uh, I'm kind of unreachable from each one of them. No, what happened? Arrays cannot be quick fix. Hey man, don't laugh. Okay, chalo, ठीक है. So we have filled the array with an infinite distance, right? So do we require a starting position and ending position also?
Yes.
Starting x, comma, starting y. We also need ending x, comma, ending y. Okay. So let's take those inputs also. That is my starting x is x coordinate of the night. Okay, and probably we can just copy paste, right? Okay, so we are done with taking the inputs, I mean where we have to go and where we have to reach, right? Now what we will do a BFS from where,
Yes.
Starting way.
right? And finally system dot out dot println distance of ex comma ey. Can I say this? Distance of ex comma ey will tell me what is the distance needed to reach. Okay, now we will have to start with our BFS. Question to you guys. In BFS, we have created a queue of integer, correct? Queue of, where it is? Queue of integer. But now we have two coordinates. So what shall we do? Queue of what?
Queue of list.
List. List is not a good option, right? Because list is
Key
something,
value
I
plus.
mean, you can use, obviously, you can use.
We
So
can create a custom class.
yeah, that's a good. So when in Java, like when you go for kind of this coding round, you can actually use a custom class, right? X comma y, which will tell that you are modeling your problem into a object oriented level, right? So it's better
Um,
to create a something, let's say pair class. Okay. Okay. So you know, right? We will just create a quick constructor. This dot y equals to y. So first thing first, queue of pair. Okay, is it clear that
yes.
now we created a pair type? Okay, so what we need, q dot add of new pair of x comma y, since I am starting from here. Okay, remember first point, distance of x comma y will be how much?
0.
0, because we are starting from there, right? Now till I am able to travel, okay, till my queue is not empty means till I have nodes to visit. Pair, okay, maybe something pair node q dot remove. Okay, so node is where you are at. Okay, so can I say my current x Can I say this? Current x,
Yes.
current y, okay, the x and y position. Now we will take a help of these array.
DXY.
We will take a help of these array because we need to explore 8 directions, right?
Yeah.
So int equals to, okay, let's make it static. How many directions? We have 8 directions, right? So for directions equals to 0, directions less than 8, directions plus plus. That is, we are iterating on these array. Okay. Now, can I say int next x will be nothing but, is this correct? Next x. If you remember the
Yes.
diagram from x, we did x plus 2, x minus 2 something. So can I say this is correct?
Yes, yes.
Right. Next, current y plus, okay, okay. So this is what we have, right? Next x, next y. There is a chance that, let's say you are at this node and you went out of the grid. So we need to keep track of this also, right? I mean, we shouldn't go out of the grid, correct? We should be inside the board itself. So probably what we can write is, if is valid to go to next cell. Okay. We will write a custom method which will tell me whether we can go or not. Okay. Does it make sense, this if condition?
Yes, bro.
Okay.
Yes.
So we will also handle the distance case also in this valid only. Okay. Or shall we check? Okay. Maybe we will try write a better one. Okay. And if it is valid to go and we are visiting it for the first time. If we are visiting for the first time, can I say this is nothing but distance of next x, next y will be nothing but 1 plus distance of current x. Can I say this?
Yes, bro.
Right? So this one we will write it that whether it is valid to go there or not. Okay. I mean, we are just not moving out of the chessboard. And this is something as, hey bro, are you visiting it for the first time or not? Okay. If you are visiting it for the first time, please take this distance. And the second step should be, should I have to add it to queue?
Yes.
Okay. Now, if you see, our BFS is actually done. Okay, except this part. Okay, so quickly let's write that also. Okay, private static, what is this? Boolean is valid int x comma int y. So what we need to check is whether it is inside the grid or not. Okay, so if I say return, how many of you understood this?
Yeah, I got it.
Okay, others, Manan, Deva, Sam,
Yeah, got it, bro.
It's kind of pruning on the.
Boundary.
boundary. Yeah. So Manan,
Boundary.
did you understand
Yeah.
this?
If X, Y are
देखो xy कब वैलिड रहेगा जब x is greater than or 0 less than
zero.
y greater
Correct.
than 0 y less than n. अगर ये
Correct.
सब condition valid है then only
So
we
it
say
is it's inside. Yes.
so
Hmm.
this does work right for us.
Yeah.
Okay, ठीक है, and in fact you have done the code. Okay, चलो let's run it. Okay, probably, and let's see, or did we, yeah, I guess it's enough. I mean, that's all. So what we need is we need only chessboard and the positions, correct? And index and y. So shall we take 5 cross 5 chessboard
Yes.
or 8 cross 8?
We'll give 5 only. 8 will be too big.
Okay, no worries. And starting position, starting x, starting y. Please let me know. SAS with
जैसे एग्जाम्पल का ही ले लेना.
oh this is a okay fine. Let's take this probably 0 1 2 3 4 5. So
6
this is
cross.
3 0 3 1 3 2. So 3 2 is the starting and this is uh, how much? 0 1 2 3 4. So is it 0 4?
Yeah.
Oh, what happened? Weird exception.
6 by 6 है. 5 by 5 लिखे.
Sorry.
6 by 6 नहीं है क्या मैट्रिक्स जो तू लिखा?
అయినా లాస్ట్ రో లాస్ట్ కాలమ్ యూస్
हाँ.
So we got something as distance array. Didn't we initialize? We initialized it. Okay. 31 23. 31 is this, 23 is. So as soon as we go here, we are getting uh, what? Array index out of bounds. So index out of bound gaya. Where is the problem? So we have taken only one n, right? It's not double five. It's only one five.
N का M.
Exactly. Okay. So what we need is we need only one n, and then we will take this that 3 2 and 0 4, and now we get 3.
నైస్.
Okay. Clear?
Nice.
Yeah.
Yeah.
Sam,
Yeah,
especially
clear.
this one, this dx dy.
Yeah.
Yes, yes. Like that day we thought to discuss in the graph.
Yeah. Okay. So this is a very good technique. Okay, that going like this. Okay. So are four of you clear on this? Man, I hope you
Yes.
like
Yeah,
this
yeah.
problem. Okay, and this is very good fun. So BFS में this kind of modifications will only come. Okay, there is nothing else in BFS that you have to do something. मतलब hard है तो obviously it's hard, but at least medium level problems में you do little bit of tweaking here and there and it passes. Okay, nothing extra. A homework problem for you guys. Okay, we wouldn't be taking this because we don't have enough time. Homework problem is again same. Given a grid, okay, there is a grid. You're given a starting point and you're given an ending point also. Okay, there are some there are some cells which are blocked. Okay, there are some cells which are blocked. Something like this. What you have to do is you have to take a starting position and ending position as like we did in our previous question of the night. You have to count the, I mean not count, you have to tell me the what's the shortest path from start to end. Okay, and obviously you cannot go via wall, right? I mean blockage, so you have to go like this, maybe something like this. So the answer is 1 2 3 4 5 6 7 8 9 10 11 12 13. So 13 steps, so you should and print 13. Okay,
Smallest ना.
smallest, but you should not go via, I mean walls आया तो you cannot go.
हाँ तो तू सीधा जाके राइट ले ले. उतना क्यों गोल घुमा? Like you go straight set. अच्छा हाँ. हाँ.
స్మార్ట్.
Nice.
हाँ ठीक है.
Okay, yeah, that was correct Manan, but yeah, like we समझ गया.
Yeah.
So this is how we should manipulate with people. There was a block, man. You didn't see Manan. Okay, that's why.
Ah, I didn't see. My mistake.
Okay.
వై
So,
రికార్డింగ్.
oh, okay, okay, okay. We have